Welcome to Electron Tech channel. In this video, we are going to see casual and non-casual discrete time system. Before seeing the system, now we will know about the real-time example for the time index n, n-1 like that. Okay. Now, there are three cases: present, past and future. For example, we'll take a real-time example as n as today. N we consider it as today. Then past, that is yesterday or day before yesterday, that we can write like yesterday we can write like n-1. Day before yesterday we can write as n-2. That minus, after n we are writing minus, that is called as, that indicates that it is past. Then for future, to write tomorrow, after n we have to write plus n. That plus indicates that it is future. If it is day after tomorrow, we can write it as n plus 2. Then input and output we will see now. Input is x of n, output is y of n, that we all know. To write the past input, after n we have to write minus, like yesterday or day before yesterday. For past we have to write minus after n. For future we have to write plus. X of n-1, x of n-2, x of n-3, etc. are past inputs. X of n is present input, x of n plus 1, x of n plus 2, x of n plus 3 are future input. Similarly, output. We all know that y of n is present output, then past output y of n-1, y of n-2. Similarly, future output y of n plus 1, y of n plus 2, y of n plus 3. Now let us see casual system. If the output of the system depends on present and past input, that we can call it as casual system. Here an example is given. Y of n is equal to x of n plus x of n minus a. Here y of n is present output, x of n is present input and x of n minus a is past input because n minus. Then we will see the condition for causality. Suppose if h of n is given, that is impulse response is given for an LTI system. LTI system is linear time invariant system. It will be casual if the impulse response is equal to 0 for n less than 0. This is the condition for causality. Then next one is non-casual or anti-casual system. Here the output depends on future input. Now we can see the example y of n is equal to x of 2n. Here the 2 indicates n is multiplied with the 2, that it is a future input. So our present output depends on future input. It is physically unrealizable and in pre-recorded signal, future values are available at the time of processing. Now let us see an example problem. Here y of n equation is given, that is the system equation. We have to determine whether the given system is casual or non-casual. For that, first we have to take three values for n. For n, one positive value, one negative value and n should be equal to 0. These are the three cases. First let us take as a negative value, we can take n is equal to minus 1. This n is equal to minus 1 we have to substitute in the given equation. After substituting we have to simplify it. If we look at y of minus 1, then it is equal to x of minus 1 plus 1 by x of minus 3. In this equation, y of minus 1 is present output here, x of minus 1 is present input and x of minus 3 is past input. So our system depends on present and past input. Similarly in other cases, if n is equal to 0 and n is equal to 1, The output depends on present and past input. So the given system is casual. Now we will see the next problem. Here the given equation is y of n is equal to x of n squared. Here also we can cases n is equal to -1, n is equal to 0 and n is equal to 1. In the place of n, we have to take the y of n equation. In the y of n equation, in the place of n, we have to substitute the n value, whether it may be -1, 0 or 1. If we look at the three answers, here n is equal to -1, then y of -1 is x of 1. So here the present time index is -1, but we are getting future input x of 1. So this system is a non-casual system. Here in this example, if we take some other values of n also, except for n is equal to 0 and 1, for all other values the output depends on future input. Hence the system is non-casual. Thank you all. Kindly subscribe to my channel. Thank you.